Hello, students. Welcome to Lesson 4, Types of Chemical Reactions. There's our outcomes. Okay, so quick review. Remember, we have elements and we have compounds. Okay, elements are just standalone, and compounds are two or more elements put together. Okay, now we're going to talk about these things called chemical changes. Okay, so you can have what's called a physical change or a phase change, which is the same substance just changing state or phase. So when I show you this, notice the substance here is the same. And with all chemical reactions, you have a left side of the equation over here and a right side. And the left side is like before, and the right side is after. So you could have H2O, and notice its phase. Let me erase all those. H2O is in liquid form right here. And then after something has happened, we have a gas. In other words, water boiled and turned into steam. H2O gas would be steam. Okay? All right, so that's a physical change. The substance didn't change. It's still H2O and H2O, but the phase changed, the state of it changed. Okay, next. We can have a chemical change, and that's when the substance actually changes. Okay, so let me put some things up on the screen here. Okay, so a substance change means this substance and this substance changed. They're not the same substances on this side anymore. We don't have a CH4 over here, right? Okay, so the substance has actually changed, whereas here, H2O is still H2O. When you have a substance change, it's called a chemical change, okay? And there are some evidence. There's evidence of a chemical change. Okay, so here's the evidence. Let me clear all those. First evidence is appearance. If the appearance has changed, you probably have a chemical change. For example, a wooden log starts out as a log and it turns into charcoal. Well, the appearance has definitely changed. Light was given off because it was on fire, right? Heat was given off. If the appearance changes and the light changes and the heat changes, it is probably a chemical change. The odor can change. So cooking a steak, right? The odor changes. Bananas changing color. If there's a color change, that's a chemical change. So that's some evidence. Now with the water, it did change. It got hard, right? So, it was in liquid form, and then it boiled, and I was thinking of freezing. It boiled and turned into a vapor. So, like, you had this hard substance, and then it was gone. So that might trick you to thinking it's a chemical change. But generally, these tell us if we have a chemical change or not. Okay? All right, next. Now, when we're talking about chemical reactions, we're going to talk about 4 types. The first type is just a simple composition, which is when you have an element plus an element, and that makes a compound. Imagine like a red piece of Lego and a green piece of Lego makes a red-green, okay? So composition means you're building. You're adding 2 together to make a bigger one. Decomposition means we're going the opposite way. we have a compound that breaks into its smaller pieces of elements. So two pieces of Lego break into this piece and this piece. Okay? Then we can have a combustion reaction. Combustion is burning. Okay, like lighting that log on fire. Burning gasoline in your car. They're always the same. There's always what we call a hydrocarbon, which is just some kind of a CH compound. And it's always plus oxygen, always makes carbon dioxide, always makes water. The difference is how it's balanced. This substance always is different. Like it's a different hydrocarbon. Like you might have this one, C2H6, or propane, C3H8. They're always hydrocarbons, C's and H's, but these numbers different. And it's always oxygen, CO2, H2O, but the numbers out front might be different. So if I clear this, on one you might balance it like this. On another one it might be a 3 here and a 5 here. Okay, so that's what's different. And then a neutralization reaction is just when you have an acid and a base and you make something and water. So acid, HCl. Oh, you know what? I made a mistake right here. I'm going to fix this. If that's an acid, it has to have aqueous there. And this has to have aqueous. I didn't put states on any of those, and I should have. Anyway, this is acid plus base. And notice on this side, there's no acid and no base. You have this salt, and we make water. Okay? So that's a neutralization reaction. The acid and the base essentially killed each other or neutralized each other. All right. Now we have to talk about balancing equations. Okay, so there's a whole bunch of little rules here. So I'm going to just stick with, let's see, with that. Okay, let's go over this. Okay, when we're balancing equation, we have bottom numbers. That's just my term. This is a bottom number. They're the little numbers. We have front numbers. Now, wherever you don't see a number, it's a 1. So it's actually like this. There's a 1 there and a 1 there and a 1 there. A 1, a little 1 behind the NA, a little 1 behind the I. Okay, now, bottom numbers are set in stone. You can't change it. We are not changing any of these bottom numbers. Those are set in stone. They're unchangeable. Okay? But the front numbers can change, and you're going to see me do that in just a second. The front numbers can change. Wherever you don't see a number is a 1. Okay, so if I clean up this screen, I'm going to put my 1s back in. In chemistry, the left side must equal the right side. So my before side has to equal my after side. Okay? And in chemistry, I can take my bottom number times my front number to make the left side equal the right side. So bottom number 1 times front number helps me to do the math to make the left side equal the right side. Okay, 1 times 1 is 1. I have 1 NA right there. And if I go over here, 1 times 1 is 1. I've got 1 NA right there. That means it's balanced. In chemistry, the before side has to equal the after side, or we've disobeyed the law of nature. We destroyed something, made it disappear from the face of the earth. Impossible. Or we created something. We can't create matter. We can't destroy matter. Okay? All right. But there is a problem here. Look at this one. Bottom number 2 times front number 1 equals 2. There are 2 I's right there. But over on this side, now don't look at NA right now. Just kind of cover up NA in your mind. Like, don't even think about it. I got 1i times the front number 1. 1 times 1 is 1. That's not balanced. If I've got 2 over here, I have to have 2 over here. So I'm going to clean all that off. Get rid of all that. All right. So if I have 2 on this side, I can change this front number and make it 2. And now I've got 1 times 2 is 2. And here I can do it either way, bottom number times front, or front times bottom, either way. I can go 2 times this one. Remember, I'm not worried about the NA right now, is 2. Okay? All right, so right now, if I was to clean all this off, right now, here's what I have. I'm going to erase this. I have a 2 here. Now, let's just look at the NAs. Let's just look at this. How many do I have? I got 2 times 1 is 2 NAs. And I look over here. 1 times 1 is 1 NA. So that doesn't work. They have to be balanced. So I'm going to put a 2 right there. And now I have a balanced equation. So what I did right there, I went really slow and complicated, but it can be way faster than this. So let me clean this all off. Erase all strokes. So I can see I've got 2 i's there. I got to put a 2 out front to make 2 of those. And because I have 2 NAs now, I put a 2 right there. So if I was to clean this up, I have 2 NAs. There, that's balanced. My front numbers, they're called coefficients, but anyway, are 2, 1, 2. Okay? If I was to draw this, let me start over. If I was to draw this, I got 1 NA, I got an I and an I, and here I've got an NA connected to an I. Not balanced right now. So I've got 2 of these, so I got to make 2 I's, but because these are connected, I can't just throw in an I. I actually just make a second NaI. Now when I count, like I put a 2 there, now when I count, I've got 2 I's, but I've also just made 2 NAs, so I got to put an NA over here and make that a 2. So the balancing is 2, 1, 2. Okay? All right. Let's try another one. Okay, if I was to draw this, I have an NA, and I got 4 P's. And I got this substance, which is Na3P, so I'm going to put Na, and it's a compound, so it's somehow connected together. Na3P. Okay? All right. Well, first thing I got to do is look what I've got. I've only got 1 Na. Whoops. I've got 1 Na there, 4 P's there, 3 NAs, and 1 P. Right? Okay, so usually you just take the highest number on the left-hand side. Oops, dang it. Oh, there we go. Usually I just take the highest number on the left-hand side and just go with that. So I know I got 4 P's here, so I'm going to put a 4 out front. And that means this little 1 that's here, 1 times 4, don't worry about these. 1 times 4 is 4 P's, right? But when I just did that, I made kind of a mess of things. I made 4 Na3Ps. I made 4 of those things. So now I'm going to draw them in so you can see. I'll put this on too. Yeah. What I did when I put this 4 out front, when I put that there, I made 4 of those chunks. So I have an Na 3P there, and I made another one. And another one. I made 4 Na 3Ps, right? I made 4 of them. 1, 2, 3, 4. Okay. Well, how many NAs do I have now on that side? I've got 3 times 4 is 12 NAs. You can see them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I got 12. So to balance it, I got to go put a 12 over here. And then I could draw all those in. 1, 2, oh man, 3, 6, 7, 8, 9, 10, 11, 12. Ooh, I've got 12 of them there. They're separate. Here, these NAs over here are connected to stuff, to the P, the phosphorus. But they're NAs. There's 12 of them. Okay? So if I clean this whole thing off, I have 4 P's there, so I need to put 4 here. 4 times 3 is 12. I need to put 12 there, because 12 times 1 is 12. Cleaning it off again, I've got 12, 1, 4. There. That is your balanced equation. Okay, you just need to go ahead and try those. There's a whole bunch of balancing questions to do in your booklet. You try them and you see how you do. Okay? All right, that's the lesson. Thank you.